So welcome to my session. Now I need to kind of make sure I press the right buttons, otherwise stuff starts breaking. But a little bit about myself. Why am I standing here today? Why did Philip ask me to tell you all a little bit about natural language processing with Python? My name is Ties de Kok. I'm a PhD student, a fifth-year PhD student at Tilburg University of the Netherlands. And one of the things that I kind of specialize in is I try to bridge the gap between computer science and empirical accounting research. I don't have any background in computer science. I don't have a master in data science or anything of the like, but I find it terribly interesting. It's something that I've always been very interested in. And early on in my PhD, when I realized that this would be something that there would be a demand for, I kind of went all in to make myself as proficient as I could with Python or programming in general. And one of the things that I think is particularly useful for us as accounting researchers is to use it to process text. So that's one thing that I kind of specialize in particular, and that's what I'll be talking about today. So the goal of this session is to introduce you to the basic concept of textual analysis, natural language processing, to highlight a couple of the main techniques, and to give you some paper, some references that you can kind of look up if you were interested in doing this to see how accounting researchers or finance researchers are actually using that particular technique. But one thing that I will not do is I will not start programming here in front of you because we just don't have time for that. I'm not requiring you to have a laptop to start programming with me because by the time we actually get to the thing that we're interested in, we will be 45 to an hour minutes into the session, so that's not very productive. But obviously, if you're interested in actually starting to program this for yourself, for your projects, whatnot, I have very extensive Python tutorial notebooks on the basics of Python, but also on natural language processing, which is very comprehensive. I'll highlight these whenever it's necessary, but if you're interested in actually programming yourself, then you can kind of take all the conceptual knowledge that I'll present to you today, look at the examples that I have, look at the practical recommendations that I have on my GitHub repositories, and kind of start from there, okay? What will I not do? This is also important to kind of communicate. I will not focus on the real technical, the real mathematical details. Because particularly with natural language processing, there can be a lot of math, there can be a lot of technical aspects to it. Personally, that's not the way that I see it. I see it more from a practical, I have a problem, I need to solve that problem, how do I solve it? And the mathematical skills is just kind of a part to make sure that what I do actually does what it's supposed to do and it does that in a robust way. So I'll not focus on that. I'll focus on the concepts, where I think you can apply them to, and how you should apply them, and maybe I'll highlight a couple things you need to pay attention to, but that's all with regards to the mathematical part. I will not throw buzzwords at you for an hour, because that's very easy to do with natural language processing. I can just go through the whole vocabulary that natural language processing programmers use, and kind of be like, okay, this term, that term. I'll try to minimize that as much as I possibly can, because that is not too interesting. But if there's really an important term that I think you need to know or that you need to intuitively understand, I'll highlight it and I'll tell you what I think the appropriate layman's definition is, okay? And finally, I will not provide you a comprehensive literature review. I have examples of the literature per technique, but these are just examples, okay? There's many more, and there's just too many for me to include in this presentation. So please don't take it as a comprehensive literature review, just a couple of examples, okay? Finally, natural language processing, there is really a lot to it, okay? There's many different components to it, and some components might be more or less relevant to what you actually do, but I obviously don't know what your particular preference or your particular use case is, so I just kind of take a bird's eye view and show you every little component, but all of the details I have excluded in the slides that I will be presenting, but I will make sure that these extra detailed slides are available on the ARC blog post that I will make after this session, where you can find the slides, and I'll kind of put the whole slides, the full set of slides there so that you can look up all the details for that particular technique, okay? So in the slides that you'll find later on, there's going to be some slides that I'm just going to skip here, yeah? Okay. And if you don't know what the ARC platform is, I guess in the prior session that was introduced, but that's the platform where I will put my slides. I'll make a blog post to kind of help you start with all of this, put an overview of all the different materials, put a link to the slides so you can take it from there. Yeah? So you don't need, you will get all the slides. You don't need to kind of take notes from them. If you want to, you can, obviously, but I'll make everything available. Yeah? Okay, so this session, what will I, within the world of natural language processing and text analysis, what will I talk about and what will I not talk about? The things that I will not talk about is, first of all, determining the relevance of textual data for your particular project. Because for some projects, going into textual analysis is a thing you should do. For other projects, it's an unnecessary complexity. Yeah? This is an important choice that you need to make before you get started. Because if you start to put in a lot of time into this, and you can sink a lot of time into this, but it's not worth the effort, you're just wasting your time. But that's going to just depend on your particular research project, so I cannot really say too much about that for your particular use case. I will not talk about different sources, because when it comes to text, there are sources everywhere, okay? One particular source where you can find a lot of textual data is by web scraping, gathering data from the web. I have some tutorials of this as well, and I'll make sure to include these in my ARC blog post. So if you're interested in that aspect, just go there and look it up. And finally, the actual task of gathering it, I'm also not going to talk about that because that's more web scraping, that's more loading in files. I have examples of that in my code, so I just refer you to that, but I'm not going to use that. I'll talk about that in a slides. So what am I going to talk about? I'm going to talk about everything that will follow up from the point in time where you have the textual data that you're interested in for your project. Okay? So I'm going to kind of take it from the point where the data is ready, your text is available, and then how do you process the textual data, and second, how do you analyze it? Okay, so how do you take it from the text file all the way to the point in time where you're actually going to put it in your, let's say, your OLS regression or whatever regression that you run. Yeah? Okay. Very briefly, you've already heard me use a couple different terms, textual analysis, natural language processing. Is this all the same thing? Technically, no. There's kind of 4 different terms that people use: computational linguistics, textual analysis, text mining, and natural language processing, and a couple of other ones. Now, for the sake of this session, you can kind of treat them all as the same thing, okay? There are slight nuances between them, but for the sake of simplicity, just whenever I mention textual analysis or whenever I mention natural language processing, I kind of refer to the same thing, okay? The thing that I'm referring to is using text and somehow converting that into something numerical that you can actually use for analysis. Yeah? One just kind of word of advice, whenever you look on the internet for a particular thing, like how do I count tone words, whatever, and you use natural language processing as your term, and you cannot find what you're looking for, just try these other terms as well. Okay? Because particularly books, they tend to focus on one particular element, but because they all kind of relate to the same tasks, it can be helpful to just interchangeably switch out some of these terms, and maybe you'll find the thing that you're interested in with a slightly different term. So which programming language to use? Now, my preferences is obvious from the title, which is I'm a Python guy. I like to use Python as much as I can. But when it comes to natural language processing, textual analysis, I think there's roughly 3 different options that you have. There's many more options, but just for the sake of being comprehensive or being short, these are the 3 main ones you might encounter on the internet. My advice is, if you haven't done any of this before, start with Python. Okay? In my experience, that's the easiest to pick up, the easiest to get started with. If you already know how to do these things in R, or you already know how to do these things in Python, or in Perl, sorry, you're maybe better off just sticking with that particular language, just because if you already know how to do it, I mean, it's not my role to start telling you to start all over again with Python, okay? But my advice, Python is kind of the fastest growing language, both within the data science sphere, within academia, but also just in a general sense. So all the future resources, the majority of them are probably going to be Python, okay? So just is it worthwhile investing your time in Python right now? I think definitely yes. Because it's growing very fast. If you compare the current kind of world of natural language processing or Python compared to even 3 years ago, there's a big movement, a lot of new things coming up, and I expect that just to continue, if not even stronger, okay? Plus, in my experience, Python tends to be the easiest to use. Now, this is an objective thing, obviously, but So my advice, start with Python, okay? How do you start with Python if you've never used Python before? I'm not going to talk about that in this particular session because this is about textual analysis. But if you want to get started, I have a GitHub repository that has a Python tutorial, which has different examples and different kind of steps you can go through to start all the way from the very beginning, how to get everything set up to the point where you can start using Python for data handling, for visualizations, for web scraping, and for natural language processing. Okay, so if you've never used Python before, I recommend you to kind of start here because I think this is a nice starting point to start with Python if you've never used it before, okay? So we're almost at the point where I can start talking about natural language processing itself, but my final recommendation, and I stood here I think it was 2 years ago at the PhD forum advocating the Jupyter Notebook. 2 years later, 3 years later, I still use it actively. The Jupyter Notebook is a way for you to program Python code in your browser. Okay, so instead of having to use Python files or having to use a file editor, there's nothing wrong with that, but for our interactive workflow where we want to document everything, my preferred method of programming Python for natural language purposes, is to use the Jupyter Notebook. That's also the thing that I highlight the most in my Python tutorial. But I've used it for 2 or 3 years now, and I still use it every day, so I guess that is at least some token that I think it's really something that you should probably look into as a method of programming Python. Okay, now Python has a lot of different elements to it that you can use for natural language processing. This can be a little bit overwhelming because if you start Googling textual analysis with Python, you're going to find a lot of different libraries, a lot of different recommendations. So my biased recommendation is if you want to use Python for natural language processing, start with these sets of packages, okay? The NLTK package, that's kind of, it has been around for a long time. It has a strong academic support, but it can be a little bit hard to use. So there is a higher level wrapper that kind of puts some of these functions in easier to use functions, but it's the same thing, and that's a text blob package, okay? So if you've never done any of this before, that's probably a good starting point. If you want to get into the more advanced stuff, while doing everything still in a quick manner, then you probably want to look into the Spacey package. The Spacey package is relatively new. It hasn't been around for very long, but I use it all the time. I'm a big fan of it because it can do very powerful things without you realizing that you're doing very powerful things, okay? So my recommendation is start with the text blob package because it's very intuitive to use. Once you start doing it a little bit more seriously and you start to care a little bit more about accuracy and performance, you should probably move into the Spacey package relatively soon. My code examples that I will give you a link to later contains examples for both. Okay, so for the primary task, I show you how to do it with the text blob package, but I also show you how to do it with the Spacey package, just so that you can decide on your own which of the two you like the most. If you want to get into the machine learning part of it, there's really only one library that I can recommend, and that's the scikit-learn package. The scikit-learn package, it's one of my favorite Python packages, Python libraries. The documentation is awesome. The documentation for machine learning in general, it's almost like a book. Okay, they contain theoretical things you need to know, some mathematical equations, some caveats that you need to pay attention to, plus all of the documentation on how to use the package. Okay, so if you ever decide that you want to go for machine learning, start with scikit-learn because it's by far the best one out there. Yeah? Okay, so this is just a couple of recommendations. If you want to get started, this is what I recommend. All of my code examples that I have on my GitHub page or on my GitHub repositories use these packages. Yeah? That's not to say that all the other packages are complete garbage, but there's an overlap as to part of the functionality. So my recommendation is start with 1 or 2 packages and kind of stick with that. And only if you find things that you cannot do with these packages, then try to venture out into other packages just to keep it kind of comprehensive. Yeah, because if you have 10 different packages, stuff gets confusing very fast. And you want to avoid that as much as you can. Okay. Natural language processing. There's a couple of steps to it. There's a couple of paths that you can decide whether you're there's a couple of paths that you need to choose to solve your particular problem. Now, this is an overview that I made that I think roughly puts everything into perspective. Now, it's not perfect. Some elements kind of belong in multiple paths, but just for the sake of it, this is kind of a nice flow chart to put everything into perspective. So the first part, and this is one of the most important parts, and it's also the part I'm not going to talk about, is the processing and cleaning step. The processing and cleaning step is kind of the part where you load your data in, and it's just completely as is, and you somehow need to clean it up to get rid of data errors, to get rid of inconsistencies, to get rid of stuff that makes it hard to compare one document to another document. This first step is very often the most frustrating because it is very specific to your use case. So everything you need to do is just going to be specific to what you are doing. So it's hard to kind of Google for it. But everything you do afterwards, all of your analysis will kind of crucially depend on the quality of that first step, just as if you will be using regular numerical data. Yeah. Now I have a lot of slides on this, particularly on the terminology. I'm not going to, for the sake of time, discuss that here, but I will make sure that these slides are all included in the version that I will put on the ARC platform. Okay. So make sure to go through that if you're into that, because I will have all of the different terminology that you need to know with like a one-line explanation of what that means. Yeah, because sometimes that can be a confusing thing. I also have for all of these potential steps you might want to do code examples in my GitHub repository. But it's really a matter of knowing the terminology and then just kind of figuring out what your problem is. Let's say you have a bunch of text, but you need to split them into sentences. How do you do that? Well, you need to somehow figure out a function for the NLTK package or the textual package or the spacey package that you can use to do that. But I have code examples for all of this. Okay, so it's not super exciting to talk about, but it is very important. Yeah. But let's say you've done that step. How do we then translate that cleaned text data that we have? How do we clean that, or how do we use that to somehow make statistical inferences? Yeah, because we want to somehow put it into our models. We want to somehow make inferences with it. We want to do hypothesis testing, all these kind of things. Now, at that point, there's two routes that you can take. And for the sake of simplicity, I can kind of call it the simple route and the more complicated route. Now, the simple route I have called direct feature extraction. Now, that's just a term I made up. If you Google it, you're probably not going to find much of it. But what that means is you're going to take your text and you're going to immediately extract from it what you want that you're interested in. So that could, for example, be, let's say you want to know how many times positive tone words are mentioned. Okay, so then you would just take your text and start counting the number of positive words. Yeah? Maybe what you want to have is you want to calculate a readability score. You're just going to take your text, you're going to then apply a package to it that will spit out a number. Yeah? But it's just you take your text, you apply whatever you're interested in directly on top of it, and you get the number that you're interested in. Within accounting and finance research, this is what the majority of people do. Like all of these tone, sentiment papers, readability papers, they tend to kind of go this route. They just have some type of statistic that they calculate on the text, and that's it. Yeah? If you want to go more complicated, you can go the statistical route, the machine learning route. But if you do that, that's kind of the left part. You have to have an intermediate step where you somehow convert your text into a numerical representation. So there's an intermediate step which complicates things, which gives potential problems. But I'll give you both routes so that you know, okay, how would I go about doing one of these things? But in general, I advise you to always try to see if you can do it via the easiest route first. Okay? Because if you have a particular problem and you can solve that problem with the easiest method, that's usually what you want to go for first. And if you really have to, then you can just start looking into the machine learning, the more complicated stuff. Unless you're like me and you love doing the machine learning stuff, and then you sometimes just skip ahead and go to the machine learning straight away. Okay? So I want to highlight a couple things when it comes to things that we usually do when it comes to feature extraction. The first one is look for patterns in a scenario where we don't necessarily know how the text is going to look. Because let's say we want to extract an ID number, or you want to extract a name. Okay? Or you want to extract something that has a particular structure, but we don't necessarily know what the text is going to be. So in this example, for example, let's say we have two strings, two pieces of text, yeah? And one of them is Ties de Kok, and then that's my name with an ID number. and some other text. And another one is someone else, Philip Joos, with another ID number and some more text. Let's say that the thing that we're interested in, for whatever reason, to get that ID number out of the text. But we don't know exactly what this ID number is going to be, because that could be, thousands, millions different combinations. Now, in order to then extract that part of the text, we're going to have to use, it's kind of a programming in itself, but it's a very specific programming language, and it's called a regular expression. And a regular expression is a way for you to formulate, in a general sense, a particular pattern to extract text that matches that particular pattern. So in this case, for example, I don't have a pointer, but bear with me. You see like pattern re compile, that's just a function. There's examples in my GitHub repository, and there's /d/d/d, and then /w/w, whatever. That just means we're looking for a pattern that has 3 numbers, a dash, and then 2 letters. Okay? And then we can use Python or any other programming language to make it look for that pattern, and then extract everything that matches that particular pattern. Yeah? So in this case, that would extract these ID numbers. Now, I know this sounds very abstract. I might be like, why would I ever need this? But if you ever look at someone else, their code, when they're parsing, for example, SEC filings from Edgar, you're going to see that like half of it is just going to be these regular expressions. Because you might want to have this regular expression to find a particular section, the beginning of that section, to find the end of the section, to find the MD&A part, to find whatever. Okay? So these regular expressions are very important. They're very useful. If you look at someone else's code, they're going to be everywhere. But the problem is they're really terrible to use. Okay? They're really unintuitive. I use them for 3 years, and I still sometimes have no idea why it works, and it just works. Okay? So I know that's not very encouraging, but I strongly recommend, and I would show it, but I don't want to touch anything. There's 2 websites which allow you to kind of visualize what a regular expression is doing. Because like one way of doing it is just try to create a regex, run your Python code, and then just kind of see what it does and keep doing that over and over again, but that is very slow. These 2 websites, the pythex.org and the regex101.com, they visualize what a particular regular expression is doing. And then in my experience, usually once you see it, it becomes a lot more obvious. Okay? So just kind of take that, put that somewhere in the back of your mind. If you ever need to use these regular expressions, remember Thies mentioned these 2 websites, and go there and use them because they will make your life a lot easier. Okay? I use them all the time. I still use them all the time, and they're great. Yeah, and I wish I knew about them earlier. So if you use regular expressions, use these 2 websites to make your life a lot easier. Yeah? Okay. This, what I coined term counting or dictionary counting, this is what the far majority of accounting papers are currently doing. And what they're doing is nothing more, nothing less than counting words. So they have a predefined list of words, okay? And then they start counting the number of times that word occurs. A famous example is the Lofton-McDonald paper, where they have the positive and the negative tone words, right? And you just have a huge list with positive words, you have a huge list with negative words, and you then start counting how many times these words occur. Now, when you read these papers, you're going to think, well, that's pretty magical. But the reality of it is that when it comes to programming, this is the simplest thing you can do. It's literally 1, 2, 3 lines of code, okay? Because you just have your words. So in this case, let's say we have 2 lists of words. We have a list of positive words, which is just 2 words in this case for the sake of example. We have a list of negative words. We have a sentence, a piece of text, and we want to know how many times these words occur in that piece of text. Then we just loop over every word in our list, and we then use the .count function to have Python tell us how many times that word occurs, and we just add it to the total number of times that positive words or negative words were mentioned. And then at the end we get, like, let's say there's 10 positive words, there's 2 negative words, and we can then take it from there to calculate any of the metrics that you see in the literature. Okay? But the thing that I really want you to take away is calculating this in Python is super easy. Okay? That's just the way it is. It's super easy. It's very basic. But getting that first step, that word list, is extremely hard. Okay? So this approach, kind of the hard part, is not in the programming. The hard part is in the human task of creating a list that somehow captures positive words or somehow captures negative words or somehow captures whatever construct that you're interested in. Okay? So if you have a paper and you're like, I want to capture a particular construct, I want to use that approach with the term counting, make sure you realize that the hard part is getting that list. Okay? And that list, you can make that in several ways, but what people currently do is they very often just create them manually. They just kind of go through a couple documents and they're like, well, I feel this word captures that element, that word captures that element, whatever. You put all of them in a list, you run this piece of code, and voila, you're there. Okay? Now, obviously, there's exceptions where stuff can get a little bit more complicated. You want to add negation, or you want to look for a word in a particular sentence, blah, blah, blah. But in essence, this method is very simple. Okay? The word list is the real tricky part. So also, when you read these papers, be critical on the word list and less on the actual counting of words, because that's not very spectacular. Yeah? Okay. So a couple of papers that use this technique with the term counting. Well, we obviously have the law from McDonald, the tone paper, right? They create a list of positive words, a list of negative words, and a bunch of other words. And then they just count this, kind of normalize it, scale it by the total number of words or something, and then that's their measure. Okay? Another paper that uses this technique is the Garcia and Norley JFE paper. Instead of looking at positive, negative, they look at state names. So they just have a list of all the US state names. They then count how many times this state name occurs, and then they kind of use that to create a measure for geographical dispersion. But the technique is very simple, right? Just of the list of state names. They count how many times that occurs, and then there's a variation as in how many different states are mentioned or how many times a particular state is mentioned, and then they use that to create a measure. And then the other one, or one of the other ones, is there's the Brochet, Lumiati, and Serafine paper. And what they do is they create a word list for short-term oriented words, a list for long-term oriented words, and then they apply that to conference calls to get a sense of like the horizon of these managers when they are like having a conversation in the conference call. Okay, but it's the same technique. They just create a list for long-term words, a list for short-term words, and then they count these words and they create a measure based on top of that. Okay, so you can see you can use that for many different things. And this is usually kind of a first thing that you try. Because if you can figure out a word list that works very well, you obviously need to make sure that it does, then this is a relatively straightforward approach that you can use. And I think that's why a lot of these accounting papers tend to go for this, just because it's relatively easy to understand. It's relatively easy to get around. The hard part is creating the word list. Yeah? Okay. I have the references here so that you can look at them later if you want to look up what these papers exactly are. Okay. Now, the second thing for these feature extraction, you can do text evaluation. Now, this text evaluation step, it's just kind of something that I invented myself in the sense that it is a little bit of an artificial category. But what I mean here is a couple of examples. You can determine the language of a text. There's a couple of Python packages that you can use to do that. That's sometimes relevant. Sometimes you have like non-English text in your sample and you want to get rid of these. Well, how do you identify these? You can use these packages to get whether they're English, yes or no. Sometimes that's just the construct you're interested in, okay? But the two ones that I want to talk about primarily is the readability metrics, because you see these all over the place, right? Sometimes these are just controls where you have, I want to control for the complexity or the opacity of a particular financial document, the filing. And the second thing is text similarity, i.e. how similar are two pieces of documents, yeah? Now, for readability in Python, if you want to calculate all of the standard metrics, there is a Python package that does all of that for you. It's called the text stat package. You just put in a bunch of text, you tell it which metric you want, and it will spit it out, okay? Now, kind of a word of caution, always verify that it makes sense, okay? Because if there's a problem with your text, then this will not work very well, so kind of use common sense, okay? But if you make sure that everything's okay, this package will make it very easy, yeah? When it comes to text similarity, the package that I recommend you to use is and I mean, these names, I am not the one inventing them, but it's the Fuzzy Wuzzy package, okay? So the Fuzzy Wuzzy package makes it easy for you to match in a fuzzy way. It makes it easy for you to kind of calculate a similarity score using all of the different various statistical methods in which you can do that. And it does that very well. And it will just spit out a similarity score for you. So if you want to do any of these comparability things, start with Fuzzy Wuzzy package. Okay, it's relatively new. but it's at this point state of the art. It's very fast. It does what it needs to do. It's well actively maintained, so it's a great package. Yeah. So just a couple of papers on the readability. Now there's many. I just have a couple of them. We have I guess the primary one, the one that most people cite, which is the Feng Li paper, the JE 2008, where they have, or where he has, earnings, filings. He calculates these readability metrics on it to kind of see whether that relates to one another. If you want to have a good starting point, that's probably the paper you want to start with. Okay. Most of I think even all of the things that they mentioned, all of the different metrics are all in the text stack package. So that should be easy enough to replicate. One word of kind of advice is, for example, that Bonsall, Leon, Miller, and Rennekamp paper. They use a proprietary measure. And some of these papers do. Whenever they have a proprietary measure, you almost cannot replicate it just because you don't know what their statistic is, what their word list is, what their rules are to determine whether something is readable, yes or no. So that's just a word of advice from my side, a word of caution. Some of these papers are very hard to replicate. So that's just kind of like if a supervisor asks you, well, can you calculate this BOG measure, which is the measure they calculate in that paper, the Bonsall et al. Paper, know that can be very difficult just because you don't know how they did it. They used a proprietary measure from some company. We don't have access to that. I'm not a huge fan of it, but these papers get published, so just be aware that exists. Some of them are very easy, some of them are very hard to replicate. Yeah? So these similarity papers, I find these very interesting, and there's people that use these for different things, and this can be very powerful. But there's two kind of papers that I want to mention. We have the Merkley et al. Paper, or the Merkley paper, sorry. What he does is he tries to identify whether companies use repetitive pieces of text in their filings. And the way that he determines whether a piece of text is repetitive is by using a similarity score versus, I think, different paragraphs of the R&D section. So it's like if two parts of an R&D section are very similar, then they probably contain repetitive information. There's not much new informational value. The way that you calculate that is, for example, using the fuzzy wuzzy package, where you calculate the most common scores, for example, cosine similarity of any of these things. Okay, so that's what one uses to find similar pieces of text to kind of see how much of the text is actually necessary. Whether that is valid, I don't know, but that's what this paper uses it for. Another paper that uses the similarity metrics is the Lang and Stice-Lawrence paper. And there they compare in a cross-sectional manner how similar different financial disclosures are between different companies. Okay, so let's say you have an 8K filing or part of the 8K filing from one company, part of the 8K filing from another company. You can try to get a sense of how similar they are by how similar the text is. Yeah? And calculating that is relatively straightforward once you know how to calculate that similarity metric. Yeah? But there's many more different things you can use it for. One thing, kind of a practical thing that people use it for example, is let's say you need to match on company names because that's the only thing you have. But company names can be slightly different. One way you can try to solve this is by using this similarity score where you're like, okay, if two names are 80% correct, 80% the same, or 80% similar, that means that they're probably the same company. Okay, so that's another more practical application that you can use this for. Okay, now that is probably the part that most of you are going to be using because that's kind of the general first start that you want to go for. And very often that is maybe enough for the problem that you're after. Yeah. But if you're like, okay, the problem that I have is it's a little bit more difficult, it's a little bit more novel. It's very hard for me to manually create a word list that captures this. There's not a score that I can use. At that point, you might want to think about going the statistical machine learning route. Yeah, and I think this is very promising, and we slowly start seeing this more and more because once you figure out how to do this, you can solve very interesting and very relevant questions that you might not be able to solve with the direct feature extraction route. Okay. One kind of word that I want to say here is that sometimes if, for example, I do a paper and I run these machine learning algorithms, then what I can do is I can take that machine learning output and I can create a word list. Okay? And if I can put that word list on my GitHub repository or put it in the appendix of my paper, then everyone else that would kind of want to use what I have created, they just have to go through the direct feature extraction route because I've done the machine learning, I've used that to create my word list. But once that word list is available, everyone else can just use it using those basic techniques that I just showed you. Okay, so sometimes things go from the machine learning route into the direct feature extraction route, just because someone did it, someone created the word list, someone created the measure, and you can just apply it to your text and you're done. Yeah. So it's not a perfect distinction, just kind of so that you're aware. Now I'm going to talk about this very quickly. I'm just going to highlight a couple of things you might want to know. I'm going to skip over most of the technical aspects just for the sake of time. But I'll make sure that all of these slides are available. So if you're interested in that, I have examples, code examples on how you can do this. You can just go back to the slides and look at it. Yeah? Okay, so one thing I want to get out of the way is that if we have an accounting or a finance paper, one thing they start throwing at you is this term of bag of words. Okay, people love using this word, this term for some reason. Whenever people start using this term, bag of words, okay, the thing that they mean is that they just take the text, split it up into words, or tokens, if you will, and then they're just going to take that as a very big collection of words, and they're just going to pretend, they're just going to ignore that there is a certain order, that there are sentences. They're just going to ignore any of that, and they're just going to treat a piece of text as a collection of words. Okay? The reason they do that is because it's one of the easiest ways of converting the text into a numerical representation, because once we've done that, once we've just taken a text and we're like, that's just a collection of words, the order, we don't care, what you can then do is you can then start to express a piece of text as the number of times that each word occurs in that piece of text. Okay? So let's say you have a bunch of 10K filings. What you can then do is you just take all of these, you count all of the unique words that occur in all of these 10K filings, so you get just a huge dictionary of unique words, and then for each of your filings, you're going to count how many times each of the word occurs, and then you're going to be like, let's say the word financial occurs very often in one text, it occurs very often in another text, and that means that these texts kind of have the same meaning. But if there's another text that does not very often have the word financials, then that means that that text must be different. So you're going to express kind of the meaning or the information content of a text as the number of times that each of the words occurs. Yeah? That sounds a little bit complicated, but once you kind of do it once, you kind of start seeing what it is, and then you kind of get a grasp of how that works. But the goal is, let's say we have these 4 sentences, and it might be a little bit small, but we have a sentence, the sky is blue, the sun is bright, blah, 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 okay? And we're like, okay, we have these pieces of text, but we somehow want to convert these pieces of text in a numerical form. We want to express it as numbers, yeah? How would we do that in the easiest way? I mean, there's many different ways, but the easiest way is to get all of the unique words, so that you see blue, bright, can see, shining, okay? All of the unique words that are not stop words, so we're not including the and all of the is, like the words that don't contain much value. And then we're just, for each document, for each piece of text, for each sentence in this case, we're just going to count how many times each of these words occurs. So you see, for example, blue occurs in the first sentence. So then we see blue, 1 for document 1, but 0 for all the others, because all the other documents don't have the word blue in it. Yeah? And you just do that for all of the words, all of the documents, and then you get a matrix with all of these different term counts. Yeah? But then, now that we have this matrix, we can now start applying statistical methods, traditional statistical methods, but also the more newer ones, the machine learning, or even the more state-of-the-art, deep learning, all of these type of things, on that numerical representation of the text. Yeah? But the essential idea here is that we use the bag of words, we use the term frequency counts, and we converted that text into a matrix so that we can input it into statistical models. Yeah? There's many variations of this where you start scaling it by document frequency and all these type of things. I have examples for that, but I'm not going to talk about it. Okay. So once we've done this step, once we somehow figured out how to convert our text into a numerical representation, okay, there we go. Then we can somehow apply statistical analysis on it, and that's kind of the thing that we're primarily interested in. Okay, so for example, if we want to get a classification, we want to know whether a piece of text is a 0 or a 1. That could be many different things. For example, is it positive? Yes or no? So 1 or 0. Then we can start applying that onto the text using that numerical representation that we just created. There's roughly 2 categories. Now, this is not perfect, but we have the quote-unquote traditional machine learning. Okay, so that there's 2 types of that, supervised and unsupervised, and I'll show you an example of both. Using an OLS regression, as far as I'm concerned, falls under that first category. Okay, it's the same kind of technique. And then there's also all of the state-of-the-art stuff that you use when you use the Google or the Amazon or Facebook or whatever, anything with the recommendation system, or you use Siri or you use Google Assistant. Like all of that is all based on these neural networks. It's all very cool stuff, but I'm not going to talk about that here because it's not super relevant for what we do. Okay, but just so you know, that's kind of where that positions in the whole grand scheme of things. So what is machine learning? Machine learning means that you don't explicitly program the algorithm that you use to classify whether something is a 0 or a 1 or a category or whatever. Okay? Now, you do this based on input and output data. So that is your Y and your X. Now, does this sound familiar? Well, obviously it does, because a linear regression in kind of the grand scheme of things is also just machine learning. Right? We have our X variables, we have our Y variable, and we try to somehow figure out how these two things relate. And we do that by means of our coefficients, right? But it's very similar. We just have our Y, we have our X, and we have the code, the algorithm, try to figure out how we can go from these X's to the Y. And machine learning is very similar. The only difference between kind of the standard OLS regression and all of these other machine learning algorithms that we have is that these other machine learning algorithms, they tend to focus more on kind of a forecasting thing. We're less concerned about trying to explain which variable explains Y in which way, in which direction, okay? What we want to do is more of a forecasting thing. We just want to predict Y as well as we can. And maybe we need to do that in a nonlinear way. Maybe there's other ways, other optimization ways. But in the bigger picture, it's all kind of the same thing. So what does that mean? If we take, for example, the sentiment analysis, yeah? If we use the traditional method, the feature extraction, what we would do is we would first manually create our word list, right? We would be like, okay, this is a positive word, this is a negative word, and we do that for a couple of them, and then we take these lists and have Python count these words for us, yeah? If we want to do that the machine learning way, we don't create the word list, but what we do instead is we take a sentence, a piece of text, and we tell Python, okay, this sentence is positive, and this sentence is negative. But we don't give it the word list, we just kind of tell it what we want it to predict. So that is a kind of a different way of thinking, but if you can somehow figure out to get a nice classified training set, then you can start kind of take this and then have the machine learning algorithm figure out what a positive word is, what a negative word is, which of these words matters, which of these words don't matter. But all of that is done by the machine learning algorithm. Okay? So it's two different approaches. And sometimes you can use different approaches for the same problem. Yeah? But if you want to do this, then your problem kind of shifts because you don't have to create this word list anymore, but you still need to somehow classify whether a sentence is positive or negative. So as you see, like what you need to do or what you need to give the algorithm shifts. Yeah? Now, how do you get this training data? Now, the supervised machine learning version is what I just mentioned. You give it the Y's that you want it to try to predict, okay? And then it will try to figure out how to go from the X variables to the Y. Yeah? So if you do supervised machine learning, you have a training data set. And for this training data set, you already determined what it is that you want it to determine. So you already know whether they're positive and you already know whether they're negative. But that's the training set that you will give to your training or to your machine learning algorithm so that it can figure out how to go from X to Y. Yeah? Now, how do you get this training data? There's a couple of different ways you can do it. You can find a naturally classified data set. This is what very often is used, for example, for news categories, because maybe your news articles are already classified as financial news or movie-related news or environmental-related news or political news, whatever. So then you already know, okay, this piece of text apparently belongs in the political category. This piece of text belongs in the business category. So you have kind of a naturally classified set. Yeah. One other source of data that they very often use is movie reviews. Because let's say they go to Rotten Tomatoes or something and they say, okay, this one is, I give it a thumbs up, so that means it's positive, and they have a short description of why they think that it is good or why they think it's bad. And they can kind of take that text where you already know that it's positive because they give a thumbs up, right? and try to have the machine learning figure out why it is that that piece of text corresponds to a thumbs up. Sometimes you can do that, sometimes you cannot. Okay, it just depends on what you try to do. Sometimes you have to create your own training set. Now you can do that manually. I mean, nothing stops you from taking 2,000 pieces of text and just go through them manually and be like, okay, this I think is positive, this I think is negative. But depending on the number of documents that you want to classify, this can be a very time-intensive task, okay? Because you need to go through every document, and you need to somehow tell it whether that's positive or negative. And very often, once you start doing this, you realize, well, I don't even know whether it's positive or negative, or I don't even know whether it's short-term oriented or long-term oriented. And if you cannot tell, then this algorithm probably also not be able to tell. So that's kind of a good first check, that if you can relatively easily tell, okay, this should be that, and that should be that should be something else, then the machine learning algorithm will probably be able to figure out as well how that works. But if even you cannot figure it out, then you should not expect that the algorithm magically solve that problem for you, because if you cannot tell, the algorithm can probably also not tell, okay? So you can do that manually. A method that I really like and that I think that I expect we're going to see more and more is to crowdsource your training set. And this is happening already a lot in kind of the computer science, the data science world. We don't really do it, but I think it's kind of a nice intermediate way where you can use a platform like Amazon Mechanical Turk to get a relatively large sample of these people. You pay them a couple cents, and they will tell you, okay, this is positive or this is negative, okay? And that way you can have people tell you whether something is positive or negative or whatever you want it to classify, okay, without having to do it yourself. And you can do that in a cheaper way than having a bunch of RAs do it for you. Kind of the intermediate way, okay? So that's just a tip from my side. If you want to look into this, try to see if this is worthwhile looking into as well, okay? There's many different models. I'm not going to talk about these specific models because that's a little bit too technical. But a couple things I just want to point out. If you go for this route, one, machine learning is all about trying. Okay, you just want to try all of the different methods and try to see what works best. Whether something works well or not depends on your evaluation metric, and that's very important because that's obviously going to tell you whether it has a high or low accuracy. But machine learning, if you were to go that route, the mental thing that you need to think is a little bit different than what we're used to, because trying as many different combinations of all the different things you have is fine, because all you're trying to do is forecast. Okay, all you're trying to do is predict, get as best as a prediction as you possibly can in a way that it does not overfit on things you don't want it to do, right? So you want to make sure you evaluate whether it works, but based on your metric, you want to just try until you find the combination that works best for your particular problem. So there's no problem with that, okay? I have links here. If you want to look into that, just click on them and then you're good to go. There's a couple papers that do this in accounting research, not too many, but there's two that I want to give as examples because I think they're pretty fundamental. We have the Lee paper, which is he uses naive Bayes, that estimation, to classify tone and content of forward-looking statements in financial documents. It's kind of one of the first ones that really at least got attention as doing this. So that's one that people usually reference to when it comes to machine learning. But the Yigadesh and Wu paper, published in JEE, I think is also very instrumental because they also do machine learning, and they do it in a very interesting way by weighing whether the algorithm should care about certain term words more than others, and they train that based on abnormal returns as kind of a measure as to whether something is positive or negative. But what I think is very cool, or why I think that paper is instrumental, is they just do that with an OLS regression, okay? And they are very open that they could maybe have done it with naive Bayes, but in their case, just doing it using a linear regression is kind of the best way to solve their problem. But as far as I'm concerned, that's just machine learning as well, right? Because they have these returns to get a measure of whether something is positive or negative. Then they pass these different words into their algorithm and then be like, okay, this particular word is associated with very strong negative abnormal returns, so that must be a very important negative word, okay? But they do all of that just with the OLS regression, okay? So I think that's why that paper is also pretty fundamental. Okay, so the final thing I want to talk about is one very exciting avenue or a very exciting technique that we're starting to see more and more and more, and there's a lot of working papers that use this, which is unsupervised machine learning. Now, unsupervised machine learning is different than supervised machine learning because for unsupervised machine learning, we do not need to pass it training data. So we do not need to pass it kind of the classification that we want it to predict. All we do is we just give it the input data. So in this case, we would just give it the text, or at least a numerical representation of it, and we'd just be like, okay, here, try to figure out something. Yeah? Now, does this solve all of the problems? Can you use this for all of the problems? The answer is no. You can only use this for a very specific type of problem, and that is to try to find underlying clusters of documents or underlying topics. So underlying latent constructs that represent a piece of text. Okay? But for that particular purpose, it's a very useful tool because you don't need training data. So all you need to do is you just take your input data, process it, and then you just put it into that algorithm, and then voila, it will spit something out for you. It will be like, okay, this document seems to be part of this topic, that document seems to be part of that topic. There's two kind of streams that people use currently, which is principal component analysis or factor analysis. I mean, you might know that just from statistical analysis with numbers. But the one that's kind of starting to explode right now is the LDA, or latent dirichlet allocation, or however you pronounce it. Yeah. But what the LDA technique is it's an unsupervised topic model technique to discover abstract topics from a collection of documents. So you just pass it a bunch of documents, and it will try to figure out what the underlying topics are. It obviously doesn't know what these topics represent, but it will just be like, I feel this document belongs in this group. I don't know what it is, but it's a separate group compared to the other group, where this is its own kind of group, because they seem to be different. And they seem to be different on the types of words, the type of language, and all these types of things. Okay? So an example, this is an LDA that I ran on a sample of abstracts from accounting papers. Okay, so I put in these abstracts from these accounting papers, and I ran this LDA model on it, and then it spits out a bunch of statistics that you then can represent visually in kind of a way that looks like this. But then it's a little bit small, but you will see, for example, and I will try to touch it, but this is the end of my slide, so if it breaks, it's fine. If I hover over this, for example, here, you can see this group tends to have the words earnings, firm, information, analysts, etc. So that apparently means that this is probably some financial accounting, capital markets type thing. Okay, we need to determine what we want to assign to this group. Okay. And we need to tell it how many groups we want, but after we tell it how many groups we want, it will try to split everything up into a space where it tries to identify what the groups are that identify the pieces of text in the best way possible. Yeah. And one thing that you can, for example, do is I have tax here. So if I hover over text, I can see that it appears that group 6 and group 8 tend to be the ones that relate to text the most strongly. Okay. So if I were to do this, I could use this to try to identify whether that paper is a text paper, yes or no. Okay, but I need to identify which of these different groups belong to text. So that's a very discretionary choice. Okay, because that's not code. That's just you assigning that group 8 and 6 belong to text. But I mean, if we do that wrong, we get wrong classifications. But just because of the nature of how easy it is to do this, it's hard to do it well, but it's easy to do it in a way, okay? We see a lot of papers pop up that try to do this. A couple of examples. We have Dyer, Lang, and Stice-Lawrence, which is a recent JE paper. They try to evaluate whether the topics of 8K changed over time. So they take all the 10K documents in a year, they run LDA on it, and then they try to see whether like kind of this topic distribution changes over time. Yeah. We have Wang et al., which is a management science paper, also very recent. They apply this LDA technique on analyst reports to kind of get a sense of the thematic content of these analyst reports. We have also another working paper, a working paper by Bert et al. And what they do is they take 8K documents. 8K documents have different sections. So they have like item 201, 801, 30, whatever, a whole bunch of different elements. And they apply this LDA technique within each item, so that they'd be like, okay, an average item 202 item has these words in it, and then they use that to see whether firms or managers strategically position a filing in one of these different items by looking at whether kind of a piece of text for one disclosure seems kind of weird or seems to be different than an average item 201 filing. Okay, so there's many different things you can do with this, but a word of advice, you can do it and it's easy to do, but there are a lot of choices that you need to make. So if you look at these papers, try to be critical as to the number of topics that they look for, because you need to determine that. Try to be critical towards the way that they assign different groups to different topics, okay? Because that needs to, you need to do that, like the code is not going to do that for you, because it's not the magic bullet. It's not going to solve all your problems, even though you can apply it to basically any piece of text, yeah? But if you have a problem for which you really need to identify topics, this is really an interesting avenue of research that we start to see a lot of papers incorporate into their papers more and more, and I expect it to only grow in the future. Okay, I have a code example on how you can do this in my Python repository as well. Okay, so let me wrap up here. If you want to start with the natural language processing part specifically, let's say you already know how to use Python, but you've never really used it for text, there is a separate repository, which is the Python natural language processing tutorial, which is on my GitHub page. You can go to that link, or you can just click on it when I put the slides on the ARC blog post. So some closing remarks. First of all, getting started with Python and natural language processing, it can be very overwhelming in the beginning. Okay, there's a lot to it. That's normal. You just have to get over it. You just have to keep doing it. Try Google your answers. Try to find an answer. Try to get past that problem point that you have. And then eventually you kind of start to go into the routine of how you can deal with a problem that relates to natural language processing, or how you can use the Python programming language for data purposes. Yeah, but it takes some time. So don't expect that you just open everything up and you're a professional immediately, because it will take a couple of tries. It will take some problem solving, but once you get over that, it should be relatively easy to use. Finally, if you have a hard time determining what you're supposed to do, try to split it up. Just a word of advice. Particularly here, if you're like, how do I do my big classification problem that's super specific? Try to distill what the actual problem is that you're trying to solve. So instead of Googling, how do I calculate long-term terms, whatever, search, how do I count terms with Python? So try to generalize everything, try to make it specific, because that will make your life a lot easier. If you do decide to look for help, make sure that you ask your actual thing that you're struggling with, and not kind of a solution to your problem that you generated because you didn't know how to solve it in the first place. They call this the XY problem. Just look at that example. It will make your life a lot easier if you ask questions, because it will encourage people to provide a comprehensive answer to your problem quicker on the internet. Yeah? And finally, mathematics are very important, because you need to understand what these methods are doing, but initially don't get too discouraged. Because I don't have a mathematical background, and I think that I can apply these methods pretty well, but that's just because whenever I think I need to go through it, I go through the math. I try to understand why it does, why it works, why it does, why it works. But don't get too hung up to that initially, okay? Because you can use most of these techniques if you don't understand the underlying math, and just kind of go to it when you need to, okay? So I've been talking for a long time, but there is a lot to it. I hope I gave you kind of a comprehensive overview. I think we have roughly 5 to 10 minutes for questions, but if you have other questions, you can always send me an email. My email address is all over the internet, or you could just come to me after the session, or just walk up to me if you find me somewhere at the Congress. Okay? Thank you. So any questions?
So any questions, guys? There you go.
Thank you very much. If I want to calculate the positive tone or negative tone, sometimes there is a negation word before the positive and negative words. My question is there any ready-for-use package for dealing with that problem?
The answer is, because the question was, if you use these positive and negative words, sometimes you want to do negation. So you want to be like, if you left the word great, if the word not is in front of it, then it turns into a negative word, while you might think is a positive word. As far as I know, there's no like ready-to-use package for it. Yes, but I do think I have an example. You know a package? He knows a package, so I'm also interested in it as well.
So you can use, but you gotta use R in place of Python. I mean, it's. I'm totally agnostic on the tools that you can use for doing code, whatever.
Yeah.
But as far as I know, there's an available package which is super maintained in R. It's called Sentiment R, and I've been using that for quite a while.
Sure.
1 year and a half, like, and it takes into consideration the sentence structure.
Yeah. So,
So
let me put
answers
this.
the question.
This also exists for Python, okay? But if I were to answer this in a general way, so because sometimes you want to do that for positive, negative, but you also might have other reasons why you want to make sure that there are certain words that do or do not precede another word. There's no general package that I know of, but for tone, there is a bunch of packages. Like the ones I mentioned, the NLTK and the Spacey, they all tend to contain, I think the textual package as well, a function that you can just apply to a text to give you a positive or negative score. Yeah.
Here comes a new question.
Yeah.
First off, thanks very much. Very, very cool presentation. My question is, do you have any recommendation or any plan how to easily clean documents? Because that is a problem that we are currently nagging on.
Yes.
We have a very big sample of annual reports, and we, for example, want to measure the number of numerical terms, but we have the issue that, of course, there's page numbers in this, a lot of stuff of numbers that we don't want to count. Is there any practical advice you can give us?
Yeah, because this is always a very tricky thing, because this is going to be very specific to the documents that you're using. So I don't have a kind of a general rule of all that. I'll be like, this will solve that problem for you. The only kind of word of advice that I can give you is that very often it boils down to just using regular expressions. So my word of advice would be, if you have to start using these regular expressions, which I usually use to solve this problem, like if I would have page names, for example, I might want to use a particular pattern search so that I can exclude these. If you were to go to that, use the websites that I used, because they will make your life easier. Just take like a small example, put that example in that website, and just play around with your regular expressions until you kind of see that you can detect what you wanted to detect and not detect what you don't want it to detect. But it is a big problem, and it can take a lot of time. And the only real word of advice I can give is the fact that it will take some time, don't not get discouraged by it, because it's just something you need to get over with, and sometimes this can be 80% of the work. So once you finally get over that step, everything else can go pretty quickly afterwards. So make sure you realize if there's problems, you solve them, but don't get discouraged, because once you solve it, you should be able to do everything relatively quickly afterwards. Yeah? I think there was a question over there.
Yeah, sorry, it was a follow-up to the first question. It's a very naive, answer from my part, but I'm just thinking that is it possible to use a string, for example, not great in quotes, and then do a test for that to find out exactly, so that great is not misspecified as a positive tone, because you can put not great as a string in quotes in the bad list.
Yeah.
Is it possible to do that?
When it comes to Python in particular, anything is possible. So the answer in that sense is you can do anything as long as you program it. But for example, let's say you want to have not great turn into a negative word, like in combination, you can do that. But most of the times you will have to either use one of these predetermined packages, but then you're kind of stuck with whatever they use to create their classification. So if you're like, I want to use a customized version of Waffle McDonald, well, then you're out of luck. You have to just do it yourself. But you can certainly do that. You just have to add it into your code, that you make it so that it treats it as negative in that particular way. Yeah, so you'll take a string, you will look for these different words, and you're like, if this combination of words occurs in a sentence or after one another, treat it as negative, otherwise treat it as positive, for example. So you just start to create conditions to determine whether it's positive or negative. Yes.
Okay, there you go.
Probably the last one, because otherwise they take all the lunch, and we don't want to have that, obviously. Yeah.
As very often our files are just PDF files. Do you
Yes.
have any recommendation? PDF files.
Yeah. Yeah, no, that's a good, and I purposely didn't mention it. If you have to deal with PDF files, they are very hard to deal with. Okay, now usually I kind of categorize it into two categories. If you have something that was kind of a text document beforehand, and then I just converted it into PDF, you can usually just convert it back and it will work relatively well. If it's just kind of a native PDF file with pictures and everything, life just gets very hard. You can very often extract all the words, but you lose all the sentence order, the word order. You just get a whole bunch of words, and you can do with that. Sometimes you can split it up based on the pages, so that can help a little bit, but it's just very hard. Yeah, there is no easy answer to it. Yeah.
Okay, well, we maybe want to give a round of applause to Thies because, you know, they did a very good presentation. Just a very quick wrap-up for you guys because Thies made up actually three very good points. First, you are going to be researchers. We all are here. So the very important thing, you know, related to coding and, you know, machine learning and neural networks, whatever, is that you really need to take the, you know, the wheel drive. You need to drive what you're trying to do. So there is no way that you can launch an algorithm. The algorithm will give you whatever answer you might expect, and you just, okay, the algorithm worked, I'm fine. No, you need to go over the data. You need to interpret what the algorithm is actually, you know, spitting you out. So that's really important. Second thing, just a quick thing. Why the hell do you want to code? Because it's not super easy, especially if you're beginners. So the question is, why do you want to go down the path of doing Python or R or C if you're, you know, right here? Okay, why? Why do you think coding is important? I want to hear some answers because I have my own answer. Why do you think it's important? Why do you just want to stick with Excel? Or, I don't know, just Stata. You can code in Stata, but I mean, or SPSS. Why do you want maybe to switch to Python or R or C or whatever? Here comes an answer.
I think just to discover inherent things in corporate documents.
Okay, that sounds good. I'm going to say, you want to say something like real quick and then we close up everything?
I think you want to convert the textual data into quantitative data, basically to converting the qualitative data into quantitative data.
That sounds good. More broadly, you want to answer that?
I could give you my answer, and my answer is you have a problem and you want to solve that problem, and I don't really care how you go about solving the problem, but in many cases you will find out that the way for you to solve the problem is to go into the programming side of things, try to code up your own solution instead of using the pre-built solutions. But I think whether you do or do not want to engage or go down the path of going into programming Python or whatever it is, it just depends on your problem, right? Because you don't want to overcomplicate things if you don't need to. If you have a problem that you want to solve and you can solve that efficiently with Python, go for it. Otherwise, don't. I think that's, to me, the most important thing.
I totally agree with that. Let me just add one more thing, because you want to have something that's replicable. You want to have something that's completely replicable from the very start to the very end, even 1 year ahead of time. So that's one of the most powerful thing about coding. You just I can give all my code to Thies. Thies can give all his code to me, and I'm going to be able to replicate whatever he's trying to do on my own computer, because it's transparent. All right. So give again a round of applause to Thies because he has a very good presentation. Let's enjoy the coffee, not a coffee break, but the lunch that we have outside, and enjoy the conference.